Hi, myself Puja Bak, Assistant Professor of GKCM of GIS Group, Department of Electronics and Communication Engineering. Here you will find the details of my contact information, and I have developed a Facebook page where regular updates regarding this course are available time to time. Okay, in this session I am going to talk about the properties of information. So let's see the first property. More uncertainty about message, then information is more. So if a message have more uncertainty, then its information will be more. So let us try to understand by one example. So the one message having probability P1 is 1 by 4, and the another message having probability P2 is 1 by 2. And the U1 is the uncertainty of first message and U2 is the uncertainty of second message. So as probability P1 is less, mean uncertainty of P1 is more. So if uncertainty of P1 is U1, so U1 is greater than U2. Now let us calculate the information from both of the cases. For first case, let information is I1. So we know the formula of information, which is I1 equal to log base to 1 by probability, 1 by P. So here the first case, the probability is P1. So log base to 1 by P1. So the value of P1 is 1 by 4. So put this value. So log base to 1 by 4. And this 4 will go to the numerator. So log base to 4. And 4 means 2 square. So power of 2 will come in front. So 2 log base to 2. So the log base to value is 1 because it's log 2 by log 2 equal to 1. So the result will be 2 bit. So the first case information is 2 bit. Now the second case. Second case information is suppose I2. So I2 equal to here log base to 1 by P2. So the value of P2 is 1 by 2. And this 2 is also go to the numerator. So it will be log base to 2 and the result will be 1 bit. So here you can clearly see that I1 is 2 bit and I2 is 1 bit. So it means I1 greater than I2. If uncertainty is more, then information is more. Okay. So if U1 greater than U2, then I1 greater than I2 also. Okay. So now let's see the next property. The second property. So what is it? Receiver knows message being transmitted, then information is 0. Okay. If receiver knows what is that message which is being transmitted, then there is no information. Okay. So the probability of message is 1 because there is no information. So probability is very high. So it will be 1. So now calculate the information. I equal to log base to 1 by P. So probability equal to 1. So log base to 1 by 1. So the result will be 0. So it means the receiver knows message being transmitted. Receiver knows that what message is being transmitted. So there is the no information. So then information will be 0. Okay. Now let's see the third property. I1 is the information of message M1 and I2 is the information of message M2. Then combined information of M1 and M2 equal to I1 plus I2. Okay, let's see. So I1 equal to, we know that log base to 1 by P1, where P1 is the probability of message M1, and another information I2 equal to log base to 1 by P2, where P2 is the probability of message M2. So message transmitted over here, when you combine it, then combined probability that will change. Since message M1 and M2 are independent, okay, both are independent message, so combined probability that will be P1 P2. So the combined information I equal to log base to 1 by P. So P is the combined probability of P1 P2, so we can write log base to 1 by P1 P2. Okay, and we know the formula of log xy. So log xy equal to log x plus log y. So applying this formula, log base to 1 by P1 P2, so it will be log base to 1 by P1 plus log base to 1 by P2. So log base to 1 by P1 is what? It is I1, and log base to 1 by P2 is I2. So I equal to I1 plus I2. So the third property is proved also. Okay. So the last property, okay, the fourth property is, if there are m equal to 2 to the power n equally likely messages, then amount of information carried by each message will be n bits. Okay, here the message equal to 2 to the power n and the amount of information I, which is equal to n bits. So let's prove this. So now the probability of each message equal to 1 by m, P equal to 1 by m. So the same formula, I equal to log base to 1 by P. Now P is 1 by m. So put this value and then it will be log base to m. And in this property, there is m equal to 2 to the power n number of message. Okay. So now put this value of m equal to 2 to the power n. So I equal to log base to 2 to the power n. N will come here. So n log base 2, and this value is 1. So I equal to n into 1, n bits. So it is equal to n number of bits. So if there are m equal to 2 to the power n equally likely messages, then amount of information carried by each message will be n bits. Okay. Okay, in this session, I have explained you different properties of information. I hope that you have understood the session. And if you like this video, then please subscribe it. Thank you.